Therefore the absolute maximum, so absolute maximum value cannot occur at the endpoints because your function has 0 value at the endpoints, because you have f of a equal to f of b equal to 0 and we have f of x greater than 0 for some point in open interval ab. Thus the absolute maximum must occur at some point C which lies in the open interval AB. So therefore C must be a critical point of F. So C must be a critical point of F. So that means, and so C must be a critical point of F, and since function differentiable aanu, C critical point aanengil function differentiable at C aanu and C is a critical point, that means f dash of C must be 0. So function undefined avan pattilla C il, and since f is differentiable in open interval AB, so f dash of C must be a stationary point. So C must be a stationary point. So C must be a stationary point. So therefore f dash of C is equal to 0. So that proves the theorem in the second case. So therefore proof holds in case 2. So that is the case 2. So we have shown that if f is continuous in closed interval AB and differentiable in open interval AB, so provided you have f of a equal to f of b equal to 0, then there will be a C belonging to AB such that f dash of C is equal to 0. Now for case 3, so case 3 is similar to that of case 2. So we are not going to prove the case 3. So you can just write that it is similar to case 2, hence the proof will hold in the case 3 also. So same, നമ്മൾ absolute maximum വെച്ച് സ്റ്റാർട്ട് ചെയ്ത പോലെ നമുക്ക് absolute minimum വെച്ച് സ്റ്റാർട്ട് ചെയ്യാം. So using the same result, case 3 will definitely hold. So we assume that f of x is less than 0 at some point in open interval AB. So the proof in this case is similar to case 2, hence proof holds in case 3 also. So that is the proof for the Rolle's theorem. So let us see a few problems using the Rolle's theorem. ഇനി നമുക്ക് Rolle's theoremത്തിൻ്റെ ഏറ്റവും മിനിമം കണ്ടീഷൻസ് ആണിത്. സോ ഫംഗ്ഷൻ ഓപ്പൺ ഇൻ്റർവെല്ലിൽ ഡിഫറൻഷ്യബിൾ ആയിരിക്കണം, കണ്ടിന്യൂസ് ആൻഡ് ക്ലോസ്ഡ് ഇൻ്റർവെൽ ആയിരിക്കണം, അങ്ങനെയൊക്കെയാണ് മാത്രമേ നമുക്ക് എക്സ്ട്രീം വാല്യൂ തിയറം നമ്മൾ യൂസ് ചെയ്യുന്നത്. സോ ദീസ് ആർ ദ മിനിമം കണ്ടീഷൻസ്. ഇനി ഈ കണ്ടീഷൻസിൻ്റെ ഏതെങ്കിലും സാറ്റിസ്ഫൈ ആവാതിരുന്നു കഴിഞ്ഞാൽ the Rolle's theorem need not hold. So let us see an example for that case. So the differentiability condition of Rolle's theorem is critical. So for example, if you are taking a function, so let me take f of x equal to mod x minus 1. So when you take the function mod x minus 1 in the graph okay. So mod x minus 1 is not differentiable, so it is continuous in, so if you are taking these points, the minus 1 um 1 aanu, so f of minus 1 is equal to f of 1 equal to 0. Function is continuous in the closed interval, but it is not differentiable in the open interval. This point is differentiable alla. So here you can see that the slope is not defined at the point. So here you have a vertical tangent line. So in this case there is no horizontal tangent line in the interval minus 1 to 1. So when the differential, this is the case where the differentiability condition fails. So in this case the Rolle's theorem does not hold. Ini namukku Rolle's theorem there is at least one point there, f dash of c equal to 0. So f of x equal to sin x or cos x functions sin x in the case. So when I am taking the interval 0 to 2 pi, so there are more than one point c in that case. Pi by 2 il namukku horizontal tangent line undavum, aduvole 3 pi by 2 ilum namukku horizontal tangent line undavum. So there can be more than one c in that case. So let us see a problem. So find the two x-intercepts of the function f of x equal to x square minus 5x plus 4 and confirm at some point c between those intercepts f dash of c is equal to 0. So let us find the two intercepts. So f of x equal to 0 implies x square minus 5x plus 4 equal to 0. So that implies x minus 4 into x minus 1 equal to 0. So x will be equal to 1 and 4. So so we have f of 1 equal to f of 4 equal to 0 and f is continuous in closed interval 1 4 കാരണം polynomial function ആണ് and differentiable, it is continuous and differentiable everywhere, not only in the closed interval 1 4, but our only requirement is namukku adindathaanennu parnal madi Rolle's theorem parayan, and it is differentiable in open interval 1 4. So therefore by Rolle's theorem, so there exists a c belongs to open interval 1 4 such that, so we will have f dash of c equal to 0. So f dash will be 2x minus 5. So namukku 2c minus 5 equal to 0 varum. So that implies c is equal to 5 by 2. So therefore the required c is equal to 5 by 2. So there is a c between the points such that f dash of c is equal to 0. And let us see one more problem. So verify that the hypothesis of Rolle's theorem are satisfied and find all the values of C okay. So let us take f of x equal to x square minus 8x minus 15 plus 15. We are given the interval 3 to 5. So let us see what is f of 3 and f of 5. So f of 3 will be 9 minus 24 plus 15, so that is equal to 0. So f of 5 is 25 minus 40 plus 15, that is again equal to 0. So therefore f of 3 equal to f of 5 is equal to 0. So f is continuous in closed interval 3, 5 and differentiable in open interval 3, 5 since it is a polynomial. Now by Rolle's theorem, so there exists C belongs to 3, 4, 3, 5 such that f dash of C is equal to 0. So that implies 2C minus 8, 11. 2C minus 8 equal to 0. So that implies C will be equal to 4. So that is the required value of C. And let us see one more function. So f of x is x by 2 minus root x in the interval 0 to 4. So let us see f of 0. F of 0 is 0. F of 4 is, so 4 by 2 upon 2 minus root of 4 is 2, again 0 varum. So f of 0 and f of 4 are 4. Now f is continuous in closed interval 0, 4. Both functions are continuous and f is differentiable. നമ്മൾ f dash എടുക്കുമ്പോൾ f dash of x എന്ന് പറയുന്നത് 1 by 2 minus 1 by root 2 1 by 2 root x. So it is not differentiable at x equal to 0, but it is differentiable in നമുക്ക് open interval 0, 4 മതി. Open interval 0, 4 ൽ differentiable ആണ്. So therefore Rolle's theorem holds, എല്ലാ കണ്ടീഷൻസും ഹോൾഡ് ചെയ്യും. ഓപ്പൺ ഇൻ്റർവൽ 0, 4 ആയതുകൊണ്ട് അവിടെ ഡിഫറൻഷ്യബിൾ ആണ്. സോ therefore there exists C belongs to 0, 4 such that f dash of C is equal to 0. f dash of C എന്ന് പറയുന്ന 1 by 2 minus 1 by 2 root C, that will be equal to 0. So you will get 1 by root C equal to 1 varum, 1 by 2 cancel ആവുമ്പോൾ. So that implies C is equal to 1. So the required value of C is equal to 1. So the Rolle's theorem holds in this case. So here function is not differentiable at 0, but that is not required for us. We need the function to be differentiable only in the open interval 0, 4, and that holds in this case.